Hey, here we go. Number two on the test. So just keep in mind this is last year's test. First one was describing data. This one is actually a confidence interval question, but it's not a calculate the interval question. It's a do you understand what a confidence interval really means? Um, so assuming you read the question, um, and it says the owner. Okay, so he wants to check to see does this program really have a long run proportion of 20% generating um, a probability of generating a discount for customers. Owners selected a random sample, found that 15% received discounts. A confidence interval for P, the proportion of bills that will receive a discount in the long run, is that guy right there. All the conditions are met. Consider this confidence interval right here. Um, does the confidence interval provide convincing statistical evidence that the program is not working as intended? Justify your answer. Well, let's look at the interval first of all. This is A, I. Well, first of all, what's the interval? The interval is 0.15 minus 0.06, or it goes from 0.09 up to 0.21. Or for you percentage kind of people, that's the same thing as, um, let's see, 9%. 1, 2, 9%. Yeah. Or 21%. Okay. I don't know what I'm thinking there, thinking ahead or whatever. 9%, 21%. Okay. And he wants to know 20%. Okay. So, does the confidence interval provide convincing statistical evidence of the program is not working as intended? Justify your answer. Um, well, what do you guys think? I know now you're talking to your computer or your phone or whatever it is you're looking at this on. Um, well, 20% is in this. What? First of all, I say 20% is in this. Well, what does this mean? First of all, that's an interval, and this is the key to this whole problem. Because if you don't get what I'm about to say, then you'll probably lose points. For the remainder of the problem. This is an interval where we think we're whatever confidence level percent, 90%, 95%, 99%, that we think the true proportion. This is a little bit less, and you don't have to write this obviously on your test. The true proportion P lies in with some confidence. Okay, so the true proportion lies in here, and the true population proportion, I should say. Right? And so, since 20% lies in here, 20% could be the true population proportion. So back to the problem. Does the confidence interval provide convincing evidence that the program is not working? Well, for it to not be working means it's not 20%, but 20% is in this interval, so therefore I can't say that it's not working. A lot of nots in there. Since, well, I'm going to say this. No. Since 20% is in the interval, it is a possible population proportion of the percent of bills of the bills that get a discount. Okay, it says 20% in the interval. It's a possible population proportion of the bills that get a discount. There's other ways to write that, but I hope you understand what I'm trying to say. Thus, it's not evidence, right? Does that make sense? That's really all that you need to say. Since it's in the interval, it could be the actual proportion of bills that get a discount. Okay, so there's I. II or 2. Does a confidence interval provide convincing evidence that the program generates the discount with a probability of 20%? Okay, so now they're asking, we just said that 20% could be the real proportion of bills that get a discount. So 2 says, does it provide convincing statistical evidence that the proportion generates the discount with the probability of 20%? And that answer is no. Okay, any value in this interval could be the true proportion of bills that get a discount. Any value, or I should say this, no, we have evidence that any value in this interval could be the true percent of bills that receive a discount. Okay, now you need to say that there's other possibilities to get credit for this. Now, if you want to get an I for this whole problem, basically, and no credit, then go ahead and say that since 20% is close to the end of this interval, therefore it's somehow less important than if it was in the middle of the interval. Okay, don't do that, because it doesn't matter where in the interval it's in it. It's either in the interval or it's not in the interval, so it doesn't make any difference if it's close to the end or not. Okay, just keep that in mind. All right, B. Okay, random sample is taken 4 times as large as the original sample, and the second sample 15% of the bills receive the discount. Determine the value of the margin of error based on the second sample of bills that would be used to compute the interval with the same confidence level as the original interval. Okay, so we got the same confidence level. What's going to happen here? Let's just go back and think about how does sample size affect it. Do you remember for this we've got p hat? This is again a little refresher. You don't have to do it like this, but we've got this p hat q hat over n. Now what happens if I take my sample size and I make it 4 times as big? What happens to this whole margin of error? That comes out of the radical as p hat plus or minus z star. Oops, let me pull it out of the radical in the beginning. The square root of 4 comes out as 2, so it's 1/2 z star square root of p hat q hat over n. So this was the original margin of error, and I'm multiplying it times 1/2. So if the original margin of error was 0.06, the new margin of error is now going to be 0.6 times 1/2, or 0.03. This is a new margin of error. Okay, and you don't have to specifically put in numbers for p hat and q hat or z or anything like that, because we don't know what z star is. We don't know the confidence level or anything at all. Your job is simply, this would actually work, what I just wrote here. Or even if you explain in words that, hey, if you quadruple the sample size, then that actually cuts the margin of error by 1/2, because you're taking the square root of it. But you don't need to say take the square root, just by quadrupling the sample size, that cuts the margin of error by 1/2. Okay, so the margin of error would be this. So this is good enough work for that. And then C, lastly, based on the margin of error in part B that was obtained, what do you conclude about whether the program works as intended? Well, our new confidence interval is 15 plus or minus 0.03, which is 12% to 18%, and since 20% is not in the interval, we have evidence that the program is not working as intended. Okay, does that make sense? All right, hope so. Um, and the average score on this was less than 2. Um, in fact, I think I've got it here. I don't have it here. Sorry about that. I believe it's about 1.7 or thereabouts. All right, thanks.